Hi everyone, welcome to week 5 of our series on navigating the design to manufacture journey. I'm Abby Hurd from Knowledge Transfer Network, where I'm in the manufacturing team. I lead on guiding innovators with physical products with world-changing ideas that need manufacturing, helping them make sense of innovation processes, connect. At KTN, we offer a service that's free at the point of use. We challenge ideas and thinking relating to your innovation, building collaborations and networks to deliver results and accelerate innovation. So we prioritise spending our time with people whose ideas and innovations are likely to have most impact. We find that when you guys have the knowledge and insight into the innovation process, it helps us provide the right. You're better positioned to take on board the advice we provide and utilise the connections that we make. So we want to equip you with this knowledge, support and connections to help you make sense of what is a pretty tough ride. So moving an idea into production is a challenge that we find hugely underestimated. Only a small proportion of physical products ever make it to scaled manufacturing. To make this work, your plan needs to be tight and your skills and experience need to be vast. So in partnership with Product Design Scotland, we've set out to achieve two main things through this series. Firstly, we're looking to address the diverse skills and experience required. So we're going to provide insights from experts and experienced speakers with an opportunity for you to ask questions, helping you to uncover the unknown unknowns, the things you didn't realise, and dig into the known unknowns, the little niggles of things that you're looking for, and generally expand your thinking. Secondly, we're looking to help address the need for strong relationships and connections. We want to help build a diverse UK-wide community who have an interest in either navigating the design to manufacture journey or helping other people to navigate that journey. So each week we will be focusing on a different challenge that from our experience we see recurring. This week we're looking at design for circular economy, how to increase the value of your product from a whole life perspective. So circular economy in a nutshell is essentially moving from a linear product development model, a linear business model, manufacture, sell, buy, use, dispose, start again, to one where repair, reuse, recycle and remanufacture play a more prominent role. We don't just dispose of and start again. We extend product life cycles and keep materials in use for longer, reducing demands on raw materials and reducing the impact of wasted energy and product on the environment. So it's good for the planet and it's good for your business. It's not about environmental or financial benefits, it's about both. So it's really key that you consider this up front in the design stage of your journey where costs and consequences are locked in. So that's why we're covering it in this series. Increasingly markets, investors and funders are demanding this, that you take these considerations on board. So we've got three fabulous speakers today. I'm really excited about what they're going to share. They're going to cover different aspects and tell you bits of their stories as they've built businesses centred on circular economy. But for now, I'm going to hand you over to Ali McInroy, who is CEO for Technology Scotland, and Ali is going to introduce our speakers and chair the Q&A panel session. Ali.
Yeah, thanks Abby, and morning everyone. I'd like to briefly add my welcome to that of Abby's. Welcome along to this morning's session. My name is Ali McInroy. I'm the Chief Exec at Technology Scotland, who among other things run the Product Design Scotland network, who are your co-hosts for today's session. I'll be your chair for this section of today's meeting. I'll facilitate the Q&A, which will follow immediately after we've heard from all three of our speakers. You can submit questions using the Q&A function at the bottom of your screens. You can submit your questions at any time during the presentations, and we would encourage you to do just that. When you are submitting them, it helps us out a lot, because we do get many questions, as you might expect. If you could in some way identify which one of our panelists your question is directed at, it just makes it a little bit easier when we facilitate the Q&A at the end. If I could also just reiterate, could I please ask you to use the Q&A functionality and not the chat functionality. Any questions that are submitted in the chat functionality are likely to be lost in the mist, because there's all sorts of comments that go in there. Although I would encourage you to keep an eye on the chat functionality, because as you may have already noticed, we do post in useful links, etc., which might be helping you out. Okie doke. Right, not keep you guys any further. So first off, I'll introduce our first speaker, and that is Dr. Greg Lavery from Wright Office, who's going to be talking about framing your approach to sustainable design. So Greg, over to you, and I'll ask you to start sharing.
Okay, we're good to go. Give us a nod, Alistair. Is everything rolling? Great, thank you. So, hello everyone. Navigating the design to manufacture journey. So, as Abby said, it's a difficult road starting a new business, and circular economy can either be your main business or an important part of your business. So where did we start? So what I'm going to talk about at KTN's request is sort of where we've come from, where we're going, and some of the exciting stuff we're working on, and some of the challenges that we face. So where we came from is really a pretty simple and interesting statistic on sort of what's occurred in the building of buildings. And right now we're in a decade for change, and we started our business 5 or 6 years ago, and we saw that climate change was a big issue then. And now we're in a decade to address that. So we start most of our conversations, and in fact, we started our thinking about our business with a view of greenhouse gas emissions. And along with the enormous amount of waste that comes out of furniture also comprises 30% of the entire embodied greenhouse gas emissions in an office building over its 40-year life. That is an absolutely extraordinarily large figure. And that's because every 6 years on average, all of the furniture gets thrown out. Abby talked about the wasteful linear model. And we thought that's rubbish. There's got to be a better way to do things. Let's try and reduce that by 80% with remanufacturing. And along the way, we've also partnered up with flooring companies, electrical companies, wall finishes companies, and can help clients to reduce their greenhouse gas emissions on all of those furnishings by 80%, which gets you about a third reduction in your building's greenhouse gas emissions, whilst also saving money and creating local jobs. So we thought that's a bit of a no-brainer business model. Let's build a business. So first step of innovation then is, what does a business model look like that addresses this particular opportunity? Well, this is our business model, and what we decided to do was start by understanding client requirements. That's where all of our discussions start. What does the client want? We offer a free design service. We work with other designers, and also we do free audits of clients' existing furniture. So that's sort of innovation number one is well, where do you start on this journey? The second thing, then the problem that we had to solve was, well, where do we find the furniture that we're going to remanufacture? Sounds easy, sounds like there's a lot of waste. Well, what we're not doing is going to landfills and pulling furniture out of landfills, because there's a lot smarter ways to do things. So first of all, we start with clients' existing furniture, do a free audit on that, understand what can be done from that in terms of recovering, in the case of soft furnishings, completely rebuilding desks to reuse the steel in the frames, for instance, and chairs. There's a whole lot of stuff you can do as well. The second source is used furniture. Now, actually, there's an enormous, since 2008's financial crash, there's been an enormous amount of furniture coming out of offices, and a whole industry called the office clearance industry has emerged. So we work with the biggest clearance companies to source furniture. Surplus stock, we've found that most of the manufacturers are quite wasteful in how they perform with their furniture. So if something, for instance, goes into a photo shoot for a catalogue, that furniture gets put under plastic for about 3 months until the CEO notices it, and then it gets trashed because they haven't been able to sell that. So we tend to tap into those surplus stocks. And we also recognise that sometimes we have to make things new. And when we do that, we do that to our own designs with sustainable materials, with sustainable suppliers. For example, MTIB stands for the Merthyr Tydfil Institute for the Blind. So we work with a bunch of partially sighted people who do the woodworking for us to make amazing products. Our process then, now Abby also talked about how you build a circular economy process into your business. Remanufacturing is our core business, which for us is taking the long life components of furniture, like the steel frames, checking them, resurfacing, and then rebuilding the parts, the item around those particular parts with as much sustainable content as we possibly can. It's all quality controlled and engineered. And one of the innovations that we've done in our sector is we take that as an engineering discipline. I'm an engineer, my brother's an engineer, and all of our guys are mostly engineering background. So what we do is take a real engineering approach, which hasn't existed before in our industry. We do that locally, creating UK jobs. It's all quality controlled. And then we wouldn't be circular if we didn't take that furniture back, frankly. We would just be greenwashing if we were trying to pretend that we were circular. So actually we offer a guaranteed buyback and leasing options to servitise furniture, because we want that furniture back. We make more money the more lives a piece of furniture has. It gives the client confidence, it saves them money on disposal costs, and what it means is at the end of the day we're investing heavily in the furniture the first time we remanufacture it, and then we reap the rewards of that investment in later lives of that particular piece of furniture. So that's roughly our business model. So let me talk then more broadly around what we see the future. So I've talked about roughly what we do. Let's talk about where our future's going. We see that sort of 3 generations of remanufacturing or circular office furniture are emerging. Generation 1 is taking the top 20% of office furniture that's exiting offices, and that's the good stuff. That's the Herman Millers, the Vitras, giving it a fairly superficial treatment and then putting it back to use. New tops on desks, reupholstering chairs, those sorts of things. And that deals with some of the waste product. However, there's still 80% of the product that's not addressed that then still ends up in landfill or recycling. So generation 2 is then upcycling to use the next 50 to 60%. But then both of those are really only dealing with the waste problem, the outputs, if you like, from offices. Actually, we think it's more important to also work on the inputs. So how do we create a generation 3 of furniture that lasts forever? And that's a very exciting space for us. So let me give you some examples of all of those 3. Generation 1, so this is the G64. There are, to give you an idea, 50,000 of these chairs that come out of offices every single year in the UK. So there's about 500,000 out there, assuming an average life of 10 years. 50,000 chairs. You cannot believe how much space that takes up. And how difficult it is to move them all, but we do that. And we've just bought 3,000 with the option to buy another 3,000 of these chairs. Because nowadays they're sold for 780 actually is the new list price. It's the top of the range. It's won the Fire Ergonomic Excellence Award. It's a very, very good quality chair. We sell them for 160 to 210 remanufactured. You can see the quality of the powder coat on the bottom there, which we repowder coat. The quality of the arm resurfacing. It's got 100% recycled polyester fabric from Chimera. Which is super sustainable. So that's an example of generation 1. What we've also done, because we have so many of those, is created a generation 2. And this is the generation 2 of that very same chair. So polished base, we've changed the shapes of the pads. So those, and in fact, we've even improved, and so this is an example of upcycling. We've improved the ergonomics, we've improved the aesthetic, and we now have designed those pads so that we can reupholster them very quickly with no glue. So they're actually well compliant. So it's an up-to-date product that is very popular. It's one of the world's most comfortable chairs, made even more comfortable, and designed and remanufactured ourselves. And that is a premium product that we are the only manufacturers of. So that's a sort of an example of generation 2. Another example of generation 2 is, well, what do you do with old tabletops? Melamine face chipboard. If you recycle it, you get dust. There's no market for dust. So these typically end up in landfill. Well, what we do is we cut out the good parts of a tabletop and make them into bookcases, for example. So there's another example of a generation 2 product. Let's get on to generation 3. Now, this is the part that really excites us. So this tabletop you can see here is post-consumer plastic waste. Specifically, the white bits are kitchen chopping boards, and the black bits are black plastic bin bags, which are notoriously difficult to recycle or find a use for in a recycled world, on top of a beautiful Vitra frame with Vitra chairs. So very simple application of a flat plastic slab. We've then turned that into a tabletop, which are proving really popular for meeting tables because it's a bit different. It isn't this ostentatious bit of furniture anymore. It's now a values-led piece of furniture that people, or that organisations love having in their meeting rooms because it starts a purpose-based conversation with their customers. And we're going on from that to build coffee tables, for instance, and we've designed a whole table, legs and all. So this one, the top is yogurt pots with little bits of foil included in that for a bit of visual interest. And the legs are black plastic bin bags with a little bit of white in those as well for a bit of interest. Beautiful coffee tables. Banks are loving these for their private customers, branches, so that very, very wealthy people are enjoying these sort of products. And we hope to, over time, mass produce these as the price comes down, because let's face it, the price of plastic that's waste is pretty inexpensive. So in all, from that, you can see we're excited about the future in this. To date, we've done over 170 projects. We've saved millions of pounds, lots of tons of CO2, 300 tons of office furniture, and provided 6,500 of paid work. And that is real living wage employment and training for local long-term unemployed people with disabilities. So what we haven't talked about is the social aspect of the circular economy, which, given our COVID-19 new normal, and the amount of empathy and community spirit that we're seeing emerging from that, we think this is really important. We've been doing it for years now, but we think that there's going to be an increasing emphasis in that world. And the circular economy dishes that up in spades, because it's just not economical to send a product back to China to be remanufactured and back again. Actually, it must create local jobs, which are ideal for those who are furthest from the workforce. Those projects have been for a range of different clients, and we're really delighted to have won a bunch of awards, but more importantly, have some really wonderful big clients who are using us increasingly throughout their estates, and we've got some really long partnerships here, which have been really wonderful for us. So I wanted to finish with sort of the challenges. So we've talked about where we've come from, where we're going. The real challenges for us are education, which was always a pleasure to talk to a wonderful bunch of people who are interested in the circular economy, because you become our ambassadors in educating customers and your own organisations when it comes to choices for furniture, for electronics, for photocopiers, about what the circular economy is about. And there's two things that we focus on in the education. One is the quality. It's now an engineer quality control process. And secondly, the benefits. Less than half price, 80% smaller environmental footprint, including greenhouse gas emissions, and local jobs for those who need them most. So really our biggest challenge is how we show the world that remanufacturing is different from what they've seen before. It's a lot higher quality, and that those benefits are real. And the number of times we've had a conversation where someone's gone, what's the catch? And we say, there is no catch. How would you like something in less time as well than it would take to order something new? So it's wonderful to be a part of this circular economy that's emerging. That's our sort of story, and welcome questions at the end.
Brilliant, thanks Greg. Some fantastic bits of furniture in there. I only hope that we're all going to be back in offices fairly soon, that we get to enjoy these creations, so hopefully sooner rather than later. So yes, please do keep your questions coming in for Greg. I see there are some coming in, which is great. But in the meantime, we're going to move on to our second speaker. So that's Cressa Wesling. So Cressa, if you can start to share your screen and get yourself ready, and we'll pass on to you for presentation number 2.
Can everyone see? It's all working? Brilliant. So I love that Greg has given you this timeline of and also the horizons of where we are in manufacturing, because right now we definitely are looking at things like in Elvis and Cressy, we were definitely still largely in that first area where we are making the best use of waste goods. The first waste that we really fell in love with is pictured here. It was London's damaged, decommissioned fire hoses. I first came across it in 2005 when I moved to the UK, and you know, I guess a lot of people move to a new place and they go to museums and they go to, you know, different cultural sites. The first place that I went in London was the sewer, because I'm fascinated by how we treat sewage and mistreat it in this country in particular. I'm also fascinated by what we do with waste. So I think number 2 on the stop for me was the Battersea Waste Transfer Station in London. And what I saw there was so much material that I was trying to understand how much waste is there in the UK. And I like, you know, all circular businesses generally start with research in the same way that Greg's did, with trying to understand the office furniture market and why there was so much carbon in it, why there was so much waste. In 2005, you couldn't get a lot of this information online. So I then went to the British Library to just try and find out how much waste there was in the UK. And the figure that I came down to through the help of lots of librarians was that there was 100 million tons of waste to landfill in that year. And it didn't matter what I saw in the waste transfer station and what I saw in recycling centers. I wanted to get actually up close and personal with the waste to try and understand what it was. So then I started about a 6-month pilgrimage to all the landfill sites that I could get to in the UK. And I would go and spend lots of time there. And the reason I landed on Firehose is because I was in my early 20s. I didn't have loads of investment capital to tackle a 100 million ton a year problem. But when I first saw the Firehose, I thought, wow, this is quite a beautiful material. I mean, you can see in this image, it's this rich, lustrous coils of gorgeous red, and it's got a life-saving history. And I took one home. They're 18 kilos each. You know, they're quite heavy. And decided that that would be my mission, because that was kind of a bite-sized problem to solve. So rather than, you know, this is before Ellen MacArthur, this is before people were talking about the circular economy. I always was interested in starting a business that existed to solve a problem. And London's decommissioned fire hoses, which are between, let's say, 3 and 10 tons of fire hose goes to landfill every year, was a problem that I thought was right about in my wheelhouse to solve. So what were we going to do with these absolutely lovely materials? I'm just playing around with the settings here to try and work out how to move to the next slide. This is my first time not really seeing. Oh, here we go. We landed on luggage. Now, I had absolutely no interest in starting a luxury goods business. The reason why we make luggage is because we did loads of research. Again, research is absolutely key into the material itself. What is decommissioned fire hose? Where does it exist? What are its properties? What is its future potential? And we tried lots of things. You know, we made roof tiles, but roof tiles out of this material completely would have been a failure, because if you leave fire hose outside for 10 years, the UV will crack it. So there you go. We would have had leaky roofs. If you don't have it as a fire hose anymore, so a fire hose is like this, is a round thing with water moving through it. The water moving through it is what makes fire hose fire resistant at really high temperatures. When you cut a fire hose in half, it's kind of flammable, not at the same rate that, say, like cheap synthetics would be, or that dry tinder would be, but it's flammable. So leaky flammable roofs would have been a bad idea. So when we were trying to understand the properties of fire hose, it was crucial to get down to its real essence. And one of the things we discovered was that certain luxury brands, very, very famous French ones, were using nitrile rubber in their ranges, and had been since the 60s. And fire hose is actually just a more expensive version of those materials. And so if you think about what Elvis and Kressy does, we do 3 things. We rescue materials, we transform them into beautiful things. And the third thing that we do is we give 50% of our profits to charity. Now, if we want to talk about a truly circular economy, I have no interest in cutting and pasting a new set of technological norms, i.e. the circular economy and the circular flow of materials, onto an existing failed capitalist structure where it's all about extracting revenue to the 1%. Because that's a crappy world to live in, and I think we can all see from the current crisis why that's crappy. So giving 50% of our profits away is something that's incredibly important to us, because why shouldn't capital flow in a more circular way too? And when you're rescuing material from beautiful, wonderful people in the fire service, why shouldn't the money go back to them? So it seems to make sense. Kindergarten students understand this, less adults do. Gives you an idea of sort of relative intelligence. Then we came to, let's say, 2010. So the fire hose was really successful for us. Yeah, it took off. We started making only belts, then bags, then wallets. By 2010, we had solved London's fire hose problem. Just because you've solved it doesn't mean you can kind of stop, because you have to keep collecting it over time. But we were ready to tackle a new challenge, and we started looking at the world's leather waste. There's 800,000 tons of leather waste that goes to landfill every year, and this is not your old leather jackets. This is post-consumer offcut. So you've got a leather hide, and people cut out the shapes that they want. The rest falls to the cutting room floor. And that's about 800,000 tons a year. That was in 2010. And a lot of companies don't produce, they're not really honest about how much waste they produce. So we can safely say that it's significantly more than that. The words that are on the screen now is the design brief that I gave to Elvis. Because at the time, even still, 2010, people were talking about the circular economy in theory, but no one was designing for it. And I wanted to create a Lego-like system so that we weren't making a product anymore. We were making something that could be put together and taken apart and give leather, which is tanned and is going to survive for an awfully long time, the potential to have future after future after future. Elvis is very clever. So he came up with 3 shapes that allowed us to take these seemingly useless scraps and turn them into these 3 shapes that you can weave to make a rug. If you don't like a rug, that's fine. If you want a smaller rug, that's fine. If your dog bites one of these pieces out somehow and chews it to bits, that's fine. We can replace that bit. We can move high traffic pieces to low traffic areas. You can turn your old rug into a series of cubes. Not really interesting, right? But the cubes proved that we could work in 3 dimensions, and that meant we could do upholstery. And if you don't like your upholstery anymore, you can take that apart and make a bag. So this leather that had no future, because most of this waste scrap leather goes to incineration or landfill, now has several futures. And I think what was really interesting about this is that we didn't ever endeavor to be the best designers out there. We just wanted to give people the tools to design themselves. So far, very little uptake on the self-design process. Most people call us and say, can you design me something? So we haven't quite gotten to that level yet. And then for this, 50% of the profits go to Barefoot College. The reason why we make donations to Barefoot is because cows and climate change are inextricably linked. Leather, we thought would make sense if we were donating money to create scholarships for women to become solar engineers. And that's what they've been doing at Barefoot since the 1970s. It's an amazing program. Since we started, we've created 9 scholarships and completely changed the energy future for people. There's every engineer we train changes the life for 250 people. So it's already in the thousands. And I think what's amazing about that is that the circular economy has to be delivered using renewable energy. So this is why we have to be involved in projects like these. This is a bit of Elvis and Cressy's values. I think you can get the idea that we're not a traditional company in the sense of what drives us. You know, money's not really interesting to me. It's WD-40. It keeps things moving, but it's not a goal. We're always trying to achieve multiple positive objectives. So it's not enough to rescue the fire hose. You have to give back to the fire service. You have to make really cool products that are designed to be repaired in perpetuity. We make all our business decisions based on this one principle, and that's we decide, are we going to do it or not? Yeah, okay, this sounds good. Now, the last question we ask ourselves is this going to make the world better for other people's grandchildren? If the answer is no, then we don't do it. And this is a really great and helpful thing that all companies could use, because if you used something like that, you would never make landmines, you would never drill for oil, certainly not in 2020 when we know all the problems associated with that. We are a certified social enterprise, we're a certified B Corp. What's really interesting about B Corps is you have to change the constitution of your business to say that officially shareholders are not king. The earth and its inhabitants are equally as important. Just imagine that. That's just a complete rewriting of the whole Companies Act overnight. If we could achieve that globally, it would be fantastic. It would just mean that we protected the planet and looked after each other as a part of doing business. I do have a figure here, 410 pounds or 100,000 pounds. If you bury a ton of leather in the ground, it'll cost you 410 pounds. That's the landfill fee. If we turn it into our system and sell it, it's worth 100,000 pounds. So let's not underestimate the value of the circular economy. That ratio, by the way, is better than alchemy. So we're better than lead into gold with what we're doing with leather scrap. So there's no excuse for us to not be circular. It's just a failure of imagination. And the last slide I'll leave you with, because this is a really interesting audience for this project. We're just starting this. We've always wanted to make our own hardware for the bags. So that's things like belt buckles, rivets, D-rings. But we wanted to do it in an Elvis and Cressy way. And that means solving lots of problems and doing it with renewable resources. There is no 3D printer where you can put an aluminum can in one end and get a product out the other end. In the UK, we litter 16 million aluminum cans into our public spaces every year because we're horrible people. But worse than that, 2 billion aluminum cans go in the wrong bin and do not get recycled. So this is an incredible problem to tackle because we don't cherish this material. We don't love it enough to ensure that it gets recycled. And because there's no 3D printing, and because we want to do something using only renewable resources, we found that there are no designs for micro solar forges. And we've started an open source design project with Queen Mary University as our main academic partner. We just hired our project manager last week, virtually, just like this in Zoom. And in public, we are going to be designing this microforge. Cool thing about that is, if you can melt aluminum at 660 degrees C, you can create a distributed heating system. You can cook food, you can purify water, you can do lots of cool things. And this technology is free. Everyone who can use it. If we succeed, it's going to be wonderful for the world. And the two design principles behind it are, it has to be safe, and it has to be able to be built anywhere in the world for less than $500. So we're with circular, and with getting back to, again, what Greg said, that this is something that has to be done locally. The reason for us to do this project is we want to foster local distributed manufacturing, and a technology like this can really unlock that. And it's definitely what the future of Elvis and Cressy is. And if anyone wants to get involved in it, just email me, cressy@elvisandcressy.com. Thanks very much.
Thanks, Chris. It really is an absolutely fantastic story. And I'm sure you'll get plenty of questions through the Q&A, but I suspect also a lot of additional follow-up as part of that. So do keep your questions coming through. We're going to move on to our third speaker now, Ian Briggs. Oh, I can see Ian's already set up. Perfect, brilliant. Okay, so over to you then, Ian.
Good afternoon, everybody. I'm going to finish off with the last presentation around a subject close to my heart, and that's the design for disassembly, which supports the circular economy activities, which I'll explain about in a little bit more. But I'm just going to take an opportunity to explain what Aspire do and how we came about. We've got two business models. We've got one that supports zero emission products, where we build things like electric motors, electric watercrafts and bikes as well. And we also work with fuel cells. But as a former division of a leading mechanical remanufacturer, MCT Reman Limited, we've taken our know-how from there, and we are transporting that into being able to provide 3R services, so for the circular economy, for electric vehicle powertrain products, working with batteries, motors and controllers. So, design for disassembly. This is a key consideration to enable a product to be processed through the recycle, reuse and reduce processes known as the 3Rs. And it's a set of principles really that are taken at the point of design for manufacture, and is key. If it's done right, there is many benefits which I'll come on and discuss in future slides. So what is the design for disassembly? So I've actually taken a couple of definitions provided by the Hamer Centre for Community Design and the University of Manchester. But in summary, the design strategy is it's a design strategy that considers the costs and future need to disassemble a product for repair, refurbish, remanufacture or recycle. One thing that's left out of that statement fairly deliberately is the reduce aspect. And this for me is just a slightly separate, but needs to be focused on by businesses adopting manufacturing methods. And the reduce element of the 3Rs is about generating less waste and using fewer resources. So that all needs to be considered pretty much at any business stage, not just for circular economy activities. And a principle of reducing, for example, is if you've got a product with multiple fasteners in there, the idea would be to design using as few fasteners that you can manage to, to make sure that your product is still doing what it does, but you're not over-engineering it. So, that reduces cost. It also reduces the resource required to actually assemble a product together. And a simple day-to-day use for reducing waste would be to print on both sides of an A4 paper, just to put things into context. So, considerations that are required for the designer's assembly. They come in for me 3 different sort of categories, starting with the selection and the use of materials. I've listed a number of things to consider, but I've highlighted a couple that I just want to drag out a little bit more detail behind. So the choice of recycling compatible materials is pretty essential. An example of that in the automotive sector, which we sort of operate in, we've got steels and aluminiums and plastics, which have all got their own recycling routes. And, you know, there are processes and systems that do good recycling to reduce that landfill and create raw materials to be used again. But there's new products that's coming about, and I'll be specific here, composite materials. Now, they can be recycled. It's very challenging, but some of the composite materials actually, you've got no choice but to burn them, and we're trying to, you know, stop that from happening. So, and along with the same problem with composite materials, the joining technology for connectivity, they're employing adhesives, which makes it even more challenging to undo and recycle efficiently and effectively, or even use parts again to remanufacture. So most of those composite materials that use adhesives end up with some destructive testing to destructive disassembly processes, which is no use to people. And then the other key element for us is selecting materials for similar component life. So if your product's got a 12-month warranty or a 3-year warranty, you're looking to find all your components that go in there that can last that period of time as well. You know, so they've got the shelf life, they've got, you know, a lifespan of. So you don't want something designed in at an early stage that's going to fail at 6 months, because you're going to end up with an awful lot of warranty products to repair. So the second element for the design for disassembly is around the selection and use of materials. So best practices, as mentioned before, is choosing recycling compatible materials, and avoid, these are highlights again, avoid composite materials employing adhesives due to the challenges just mentioned before. And sorry, bear with me. Should have moved my slide on, apologies for that. So not to repeat that one again, but the second element is the designer components and product architecture. So again, highlighting a few key issues or key things to consider is use as few components and component types as possible. Best practices you would maximize with standardization, you know, just to make things easy for assembly. You know, changing tools costs time. So if you can create a product that has the same fasteners all the way around the product, you know, you have a time saving there. And then one thing that's very, very key, and also comes under its own umbrella of processes, and that's designing a product in a modular approach. So I call this design for assembly. So most people, designers, consider how the product gets from A to B and into commercial, but there's little thought around how you're going to put it together, and even, you know, less thought around how you're going to service it from a warranty or a recycling approach. So key for modular assembly for many good reasons. And then finally, on the consideration side, is the selection and use of fasteners. So again, standardize the use of fasteners and make sure that they're common as best as you can, because of the cost if you're putting fairly bespoke fasteners into the system. And then finally, using the joining technologies, you know, try not to glue things. That, you know, presents its own challenges. So on to the next slide, we've got a couple of examples of products I've called it, have gone through the design for disassembly and been executed. And the left-hand picture is a shot of a mobile phone that's broken down into its sub-assembly form. It's fair to say we probably all know that we've all had somebody that's got a cracked screen, or even suffered it ourselves. But today, most people can actually take their phones back and get their screen changed. Some people are competent enough to do it themselves, but that's only through the design, and it reduces that need to keep throwing those phones away into the, you know, the landfill. They can now be broken apart, as shown there, to be reused again. So why design for disassembly? So this is all about the benefits of, and doing this activity reduces manufacturing and production costs. It's, and again, I'm picking just out the key points here. It also provides product serviceability. So we've worked with many customers that, as I say, they've got the focus on what they want the product to achieve, but if it's not designed so it can be taken apart, it presents a lot of problems. It doesn't support their warranty that they would need to apply. But even at the early stage of prototyping, you don't want to spend an absolute fortune on materials and build things that you then can't take apart, because that costs you personally money to create more prototypes from more materials. So it's all about designing and thinking, how can I take this apart? And one thing clear to me is the environmental benefits of doing this. So you're reducing that landfill, you're reducing all the aspects of burning materials to get rid of them. So this is all supports the environment. And very specific to the automotive sector, it also supports their need to comply with the End of Vehicle Life Directive. So I don't know whether it's a known fact, but for us it is. 95% of the vehicle has to be recyclable. So in order to do that, you've got to take it apart as well. So that's all comes with design for disassembly. Now, to contribute to the design for disassembly, there's now new technologies about. It's been around a few years. I'd say it's at the lower commercial availability, but it's around the design for active disassembly. Now, active disassembly is about sort of components that have been designed that can be used, and then they can change their form, generally through heat and induction, that enables the product to be disassembled very, very quickly. It offers the cleanest with no destructive needs in the disassembly process, and generally is quite efficient. So the smart materials that are used at the moment are shape memory polymers and alloys. And there's an example at the bottom here of a screw that's got its thread, but when it's heated up, that thread disappears, so to speak, and then you can actually take the nut, slide the nut off. But when it cools back again, it goes back to its normal form, so you've got a threaded form. So that really does support the circular economy aspects for through the design processes. And then the next slide I've just put up is just continuing that theme. This is showing polymers, a little bit difficult with the picture up in the middle, but that's the one that highlights how this works. But at 25 degrees, you've got the fastener and the clips are closed, but once you apply heat, you can see at 60 degrees there's an opening. Right up to 75 degrees, those tabs open completely, so they can actually be disconnected from its mating partner. And then cooling back down again, it goes back to its original form. So pretty neat, and I'm hoping to see more of those types of products being made available for remanufacturers to use. And then finally, on the smart materials, this slide covers off the alloy side of it, so where nickel, titanium's used, copper, aluminium and nickel. Again, a clear indication of the benefit there is the spring that's shown on the right-hand side of this slide. Applied with induction, it changes its format, so you're able to then disconnect everything from that, and eventually that will turn back to its original form and use again. So points to consider when you're using active disassembly principles. Again, it's a common theme, is choosing recycling compatible materials. And then I've highlighted a couple of others that are very relevant, because obviously these types of materials are different, obviously, to metals. So you've got to make sure that you avoid any sort of toxic and harmful materials in these sort of active smart materials that you might want to use or design. And then a clear thing that you need to do is identify the material types for traceability to aid the recycling process. And I've put on the end there IMDS, again in the automotive sector, they have a process, it's an international material data system where they log every component from each product that goes into the vehicle, so they've got full traceability and know exactly what's going to the recyclers and to landfill. So that's another aspect to consider. And then to conclude with my slide section, just a few sort of little studies on what some of the companies are doing with their products to support their products for the original life cycle. So this slide has got 3 examples of case studies. The first one being the Cross Trainer, which is, as a design, has got a lateral support, which is a sole that wraps around the shoe, and it's quick to take apart, and it's easy for to be disassembled. And again, the Xander Peters design is a shoe that's in modular form, and it's all connected really with a long shoelace. So quite a neat piece of footwear there. And finally, there's a watch strap that can be disassembled without using tools. So there's an ease to changing the watch straps that can be used in future. And then this slide covers off very specifically what MCT Reman Limited do in the mechanical powertrain world. This is a Ford engine, a before and after, once it's gone through all its remanufacturing processes, which includes cleaning, inspection, and material recovery. But 80% of that engine approximately all the components in that can be reused again. And this enables the product to service extend the life of the product, and actually now goes to service the OEM's warranty market. So rather than put in a brand new engine when an engine's failed, they can now put a remanufactured engine, which is roughly about 40–50% of the cost of a new one. And we get the broken one back to repair. So that creates that circular supply chain model. And finally, to conclude, I've put a couple of slides in that talk about the future challenges. And these are very specific to what we're trying to achieve in the electric vehicle powertrain world. You'll see this is a picture of a battery that is a challenge in itself just to take apart. So when this is disconnected from the vehicle, there's an assumption that the voltage is at 0, everything's safe, but actually it's not. We've still got, in this particular case, this battery holds 400 volts, and there is a challenge for disassembling this product safely. So where we're coming from, design needs to be considered on how we can actually make phased stages to be able to take these apart safely. That's just one small issue of many issues, but the key one for us that we are trying to promote design for disassembly. This is a perfect example. This is a module from that battery, and we can't get to cell levels to replace a cell that is probably not functioning as it should do, because the principle of joining the cells together is done by welding. So, referencing back to the earlier point I made, adhesives are a challenge to a recycler or remanufacturer, so is welding. So an example we would apply for design for disassembly is the top right-hand picture where you see the gloved hands. There's 2 pieces of metal with their tabs, a positive and negative tab. If these were designed to have longer tabs, then the chances are of us sectioning those tabs and separating and then rejoining are increased, but that's not being considered at this point of the design. So that makes it very challenging for us. And finally, that's me. Just thank you for listening. And if you've got any questions, you can pick up on that email there, and I can answer them outside of this, or we'll do our best to answer in the Q&A session now. Thank you.
That's brilliant. Thank you, Ian. And thank you to all of our speakers. I think genuinely a series of thought-provoking and inspirational talks. And one of the big disadvantages about an online meeting is that you don't get that kind of instant gratification of a positive audience response. But I can tell you, looking at the comments coming through the Q&A and the chat box, I think you'd have all have earned your round of ovation, standing round of ovation at the end of those. Really excellent. Right, we do have a very short period of time for Q&A. We're clearly not going to get through all of the questions, but we do have a record of them, and we will make a point of trying to answer as many as we can offline if we can't answer them just now. But we should have time, I hope, for at least a question for each panellist. So we'll come to you, Greg, first, and see we're first to go. That's a question that came in from Susan, who has asked if you've ever considered mining landfill as a kind of generation 4 option, or is that just not practical?
Yeah, a good question. I think we wouldn't tackle that on our own, but I can see a couple of generations, maybe our grandchildren, actually taking that as a serious proposition. I mean, Cressy just showed the amount of aluminium, for instance, that goes into it. That's going to be increasingly viable, and I think there's going to be a whole bunch of producers of products actually, when they become circular, that generation 4 becomes a realistic alternative. So very good suggestion, Susan. I should probably add that onto the slide. Can I answer quickly one other question, which was around home office furniture? So we have just gone live yesterday, a new shop where you can purchase remanufactured furniture, or at least order it for your homes, and look at some of the sustainability of some of the particular items that you can purchase. It's cost effective, environmentally friendly, jobs in the community. Why wouldn't you buy it for your home office? Please do in large quantities and help us out as well.
Brilliant. Cheers, Greg. Cressy, if I come to you next now, I know you've already answered this online, but I think it's an interesting one just to complete the story, I guess. So the question came in, did you self-fund at the beginning, or did you have investors? And I guess the question was framed from the problem of getting mainstream funders to fund social enterprises. So just wondering what your journey was in that regard.
Yeah, I mean, we were self-funded, but I think I have to stress that those funds were really small. You know, I brought a fire hose home, we cleaned it in the bathtub. The first few fire hoses we cut with scissors to make belts, but then our hands were like these claws. So we invested £39.99 in a rotary cutting tool. And from that one investment onwards, we were cash flow positive. So if you have this attitude, like, I mean, we built our own website, which is easy now. Come on, Shopify and Squarespace and blah, blah, blah. Our first website we built, we coded on Dreamweaver. That was hard. So I think if you're thinking about a consumer product, you just have to start. I've seen way too many people who spend 2 years on a business plan and then it never goes anywhere. Just start something. Try something, get consumer feedback. Even if you're in B2B, find your ideal customers, get out there and start introducing the product. Don't spend too long thinking, oh, I need money or I need this. Because even when you want to raise money, you need a viable product in order to raise money.
Sure, thanks, Cressy, thanks for that. And I think we'll probably have time for one more question. So Ian, coming to you, this is quite an interesting point. So it relates to the use of, I guess, coatings and plastics on products, and an argument that they would normally be applied, of course, to increase the product life of those products. So does avoiding them actually contradict CE principles, or where does the balance lie there, I guess, on that?
Yeah, I personally thought it did, but in our studies and teardowns of, in particular, batteries where coatings are applied, like zinc coatings on bus bars, that sort of thing, it transpires that by recycling in bulk, so for example copper coatings, it's just a small tiny percentage of coatings. It's in the bigger scheme of things, it doesn't affect the quality of the end product. So in that particular instance, coatings is, you know, that's okay. We thought that there would probably be a negative value to that process, but it turns out it's you know, it's pretty much status quo on it.
That's interesting. Okay, no, it was great. Thanks, Ian. Thanks for that, and thanks to all of you for all of your questions. Clearly, our Q&A session is a little bit shorter today, so we haven't got through as many as we would have liked. Some of them have been answered online, which is great, and we will try and get in touch with our panelists to make sure that anything that you've submitted, you do receive an answer for one way or another. So yeah, thank you for your questions and your engagement. Thank you again to our three excellent speakers today. I thought it's a very interesting subject, covered extremely well, I felt, as part of that. And now it's just over to Abby to close off the session.
Yeah, thanks. Definitely thanks to our speakers. Like 3 great presentations. I think the comments definitely echoed that. Yeah, we will share the leftover questions with our speakers, and Meeting Mojo can be a great way to connect with the rest of the community to try and get some of those answered. We're also here to answer questions as well. There's our newsletter and our website, which will let you know about other events that we are planning to run. We've also got details of funding calls that are upcoming on that website as well. Just a little plug for the next events in our series. Next week we've got one on startup mindset and building a team. That'll be a really interactive session with some great speakers as well. Got one on IP the following week and one on investment and funding. So yeah, please tune into those. Thanks for joining us today. Yeah, just to mention, next week we're also running a webinar on sustainable plastic solutions, which might be of particular interest to this audience. So yeah, do check that out. There's a link just at the bottom there to sign up to that if you're keen. More details on our website.